Hello everyone, welcome to my channel Physics Pro. Today's problem is a solid object is rotating freely without experiencing any external torque. In this case, there are four options. Both the angular momentum and angular velocity have constant direction. The direction of the angular momentum is constant, but the direction of the angular velocity might not be constant. The direction of the angular velocity is constant, but the direction of the angular momentum might not be constant, and neither the angular momentum nor the angular velocity necessarily has constant direction. So if we have to solve the problem, we need some theory obviously. There is a rotating body rotating freely and there is a solid object. These are very important idea, and the condition is no external torque without experiencing any external torque. So let's have the idea. Consider there is a body, it is a solid object and it is rotating. Okay, so if a body rotates, there must be some axis. Around this axis the body is rotating with some angular velocity. The radius is something, say r. As we are discussing about rotating body, so rotating body have some properties, some dynamical variables. Okay, I am writing here dynamical variables. So what we need in this case to study the rotating body, number one, the omega, that is angular velocity. Okay, that's good. Second thing we need is L, vector L actually. Omega must be some vector also. Vector L, that is angular momentum. Number 3, we need some torque. Torque acts like force. This is very important because we are talking about solid object. So this is I. Why we are taking I, the moment of inertia? Because this is a solid object, moment of inertia. If it is said that this is a point object, then we don't have to inertia. We don't need to this I. Okay. Now let's go to the problem. The problem says that there is no external torque. So what is the torque? Torque is defined as dl dt, that is change of angular momentum with respect to time, and it is 0 for this particular problem. And we get from this idea that L is constant. L equals to constant, and L is a vector, so the value is constant and the direction is 2. So L has constant value and direction, right? Has constant value and direction. Okay, we got it. So here both the angular momentum and angular velocity have constant direction. Okay, but the direction of the angular momentum is constant. It could be, this could be, okay, and angular momentum might not be constant. So this is not our answer because angular momentum is constant, we have calculated. Neither the angular momentum nor the angular velocity. So this is also not the right choice. We have two choices here. The next we have to find about angular velocity. So L, by definition, L is I into omega. L is I omega. Okay, and this is constant one. This is constant, but it is a solid object and we are not changing the object. So this I must be constant. If this I is constant, then omega must be constant. If omega is constant, so omega is a vector and omega is constant, so we are writing that has constant value and direction. So it is clear that L and omega both are constant. So we are going to find which one. Both the angular momentum and angular velocity have constant direction. Obviously, if it is vector and it is constant, direction must be constant. So the right choice is